Ooh, stations. We're going to do some stations today. Here are the stations for 7.1, 7.2, 7.3, that kind of thing, where we're looking at all these different integration methods. And so let's see what we can make of them. Station 1 has 3 problems. Says use integration by parts. Oh, well, that's great, because you would never expect me to give you a hint like that on the test. So here we go, x to the third, ln of x dx. Well, that's great. And normally, I would say, since I'm doing by parts, that I want to take this and put it here. The only problem is that then this has to go here, and I need its antiderivative. And yeah, I can memorize the antiderivative of ln, but no, generally speaking, most students don't do that. So I'm going to put the ln of x here because I know how to take its derivative. And I'm going to put the x to the third here. Now, it is true that when I go and make the antiderivative here, that I'm going to have x to the fourth over 4. And that seems like things are getting more complicated, which was something we said we wanted to avoid. But, bear with me on this one. I think this is going to be fine. So our recipe is this times this, x to the fourth over 4, ln of x, minus the integral of this times this. Okay, so I'm going to have x to the fourth over 4 times 1 over x dx. And here I see that, in fact, I can cancel one of those. In fact, I can even pull this constant out in front. And so that's what I'm going to do. I'm going to have x to the fourth over 4, ln of x minus 1/4. And what do we have here? It's just x to the third. Well, that's a pretty straightforward integral for me to take. And so then my answer is going to be this integral is x to the fourth over 4, ln of x minus 1/4 x to the fourth. Bring that down. Wait, when I bring that down, there's going to be 4 over 4, but I've got so I need another 1/4. Wow, really? What if I had no 1/4 there? Yeah, that's definitely, because then that would come down and I'd have a 4, but I need a 1/4. Yeah, so it's 1 over 16, x to the fourth. That way, when this 4 comes down, 4 cancels with 4, leaving me 1/4. And don't forget the plus c. Okay, any questions about that one? Excellent. All right, let's move on to number 2. Hi, rank. Okay, so number 2 says the integral x plus 7 over square root of 5 minus x. Dx. I do want to say with this one, it really is easier to do as a u sub. I'll show you both. I'll show you the by parts way, and I'll show you the u sub way. Oh, and speaking of which, really, with stations, that means you have a test. That means really, you should be pausing the video before I do the problem. Here it is set up. Give it a try. I will say this one's a little tricky to work through, but that doesn't mean we can't do it. And I'm going to do it now. So I think this, by the way, is easier as a u sub. I'll show that second. Here, because the direction said by parts, let's do by parts first. So I'm going to plot x plus 7 there. And then I get 1 dx as the derivative, and 1 over square root of 5 minus x dx here, which means I need an antiderivative here. All right, well, so if I'm thinking about an antiderivative here, oh, look at that. That's very interesting. I didn't do that either. So this is 5 minus x to the minus 1/2. And so then what would go here would be 5 minus x to the positive 1/2 times negative 2. How come? Well, if I take the derivative, that 1/2 comes down and cancels with this 2. But what about that minus? Sure. But just like I'm taking the derivative of the outside and that 1/2 is going to come down, Look what happens when I take the derivative of the inside. Take the derivative of the inside, I've got that -1, but there's no negative there, so there must have been something present on the original function, so that when I finish taking the derivative of the inside, those negatives cancel. And so now I'm looking at 2, 5 minus x to the 1/2. Okay, so how do I do this? Well, I know that I'm looking for this times this. So I get equals x plus 7 times -2, 5 minus x to the 1/2, minus the integral of this times this. Oh, in fact, I can pull that constant out. That -1/2 times this minus will give me a plus 2 here. And we've got 5 minus x to the positive 1/2 dx. No, I'm not going to FOIL. Sorry. I will move this -2 out in front. X plus 7, 5 minus x to the 1/2, plus 2. And now my integral here, I'm going to have 5 minus x. This is going to be a 3/2. I bring the 3/2 down. The 2's would cancel, and I'd end up with a 3. Well, I don't see a 3. And my 2 needs to still be there. So I think I need a 3 on the bottom and a 2 on the top. Let's just check. So I've got 2 times 2, 3, and then I bring down that power, tink, 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 and I get a 2 left over. Oh, that's great. So that must mean that there's a 2/3 here, times that 2, so I've got 4/3. And you could certainly do like that. Remember though, all we've done now is take the derivative of the outside. We still need to account for taking the derivative of the inside. And when I do, I'm going to get a -1. So it's going to be a minus. And don't forget the plus c. Again, if you're not sure that this is correct, take the derivative. And if you take the derivative of both sides, you should be good to go. If you are able to get the same value by doing the derivative as the original problem, you've done it properly. Okay, so I do want to take a look at the second approach to this problem. This is the U-sub approach. I've seen this approach with a lot of college students. And so those of you going on to calculus in college, well, listen up. I'm going to say that u is equal to 5 minus x, because that's the stuff on the inside, right? And it's in the denominator. So that's great. And if I take the derivative of both sides, I get to u is negative dx, or that dx is negative du. Great. So I can get rid of this, and I can replace this. But what about that? Well, let's take a second look here. Remember how u was equal to 5 minus x? I really wish I knew what x was equal to in terms of u. So I'm going to solve this equation for x. X equals instead of u equals. So I'll have u minus 5 equals negative x, or x equals minus u plus 5. Great. So now I can take this stuff and put it here, and I can take this stuff and replace it with u, and I can replace this here. So now I'm going to have minus u plus 5 over square root of u times negative du. All right. Well, and my recommendation here would be actually 1, negative times positive, negative times negative, and rewrite this as u plus 5 over square root of u du. But then there's this other thing I want to do. It's a very algebra thing. I want to split this up into 2 integrals. And I want to use my integral properties to evaluate these 2 separate integrals. So what's that going to look like? Well, that's going to look like the integral of u over square root of u plus the integral of 5 over square root of u du. Okay, well, this can now be written as u to the first times u to the minus 1/2. And when we are multiplying and the bases are the same, we can add those exponents. I get u to 1/2 du, And then over here, this is the same as 5u to the minus 1 half. And how do I find the antiderivative of that? Well, that's going to be 5 times, this is going to be u to the 1 half. But if I bring down that 1 half, wouldn't I have 5 halves? I don't have 5 halves. There must be something present here in the original function so that when that comes down, there's some canceling, because all I see here is a 5. So let me put a 2 there. If I take the derivative and bring this power down, I'm going to have 1 half times 5 times 2. The 2's will cancel, leaving me the 5 that I see. Okay, so that's not integral. That's antiderivative. Let's just check this. Oh, there we go. So I did one of the integrals, this one, but I did not do the other one yet. Yeah, because this was negative 1 half and now positive 1 half. This is still just simplifying, so no integral has been taken here. So this is going to be u to the 3 halves with the 2/3 in front, plus 10u to the 1 half. That's right, don't forget the plus c. And remember, we did this as a u substitution where we said that u was this stuff. And so my final answer is going to be 2/3 5 minus x to the 3 halves plus 10 5 minus x to the 1 half, and don't forget the plus c. And yes, if I were doing something like setting this derivative equal to 0, setting this antiderivative equal to 0, I would certainly consider some factoring, but no, I'm not worried about that here. Okay, wait. There's something amiss here. I think there was a problem with my original u sub. Yeah, so hold on while I clarify that. So remember how we said x was equal to 5, we said that u is equal to 5 minus x, and that means that x is equal to 5 minus u. And so I could take this and replace x here in the numerator, this x plus 7. This x is that. And I think what happened the first time I went through is I lost this 7. And so really we should be looking at something like 5 minus u plus 7 over square root of u. That's going to be 12 minus u over square root of u. And I had 5, I didn't have 12. So I'm integrating there, and this is where I could split into 2 fractions. Yeah, I think I'll do that just for completeness. Okay, so I'm going to have the integral of 12 over square root of u du minus integral u over square root of u du. Okay, so this is going to be the integral of 12u to the minus 1 half minus the integral of, well, this is u to the 1, divided by means I can subtract the exponents, 1 half. And so I'm going to get u to the 1 half du here. Okay, so my antiderivative here now is going to be u to the 1 half. So I'm going to go with 24. So when I bring down that 1 half, I get this, minus the antiderivative here will be u to the 2/3. 2/3? No, 3 halves. And so I need a 2/3 here, so when that 3 halves comes down, there's lots of canceling, and then I just have u to the 1 half left over, and plus c. Don't forget to sub this back in, so really we should have 24 square root 5 minus x minus 2/3 5 minus x to the 3 halves plus c. All right, so that was meaningful. And what about the third problem here? Well, the third problem on station 1 looks like this. It's got ln of x on top, it's got x squared on the bottom, and then a nice little dx. And so if we're thinking about doing this problem with by parts, the first thing I'm thinking about is, well, I'm not really comfortable with the antiderivative of this, but I can certainly do the derivative of ln of x. That will be 1 over x dx. But what then will we put here? Well, what's left? We're going to take that away, and so this is x squared on the bottom, which means x to the minus 2 dx. So when I go backwards here, I want to add 1 up there. I'm going to have x to the minus 1. If I take the derivative of this, that negative 1 is supposed to come down, but I don't see a negative here. There must be a negative present in the original function. And now, as far as going about evaluating this integral, we're going to do this times this, which is going to be negative ln of x over x. And then we're supposed to subtract the integral of this times this. And so we've got minus 1 over x, that's this one, times, this one, dx. Well, minus times minus makes plus, and now I'm integrating 1 over x squared. So we've got negative ln of x over x plus the integral 1 over x squared is going to be x to the minus 2 dx. And so if I find the antiderivative of that, it's going to be x to the minus 1. Take the derivative of minus 1 comes down. Nope, there's none there. So negative ln of x over x, and don't lose that minus, or that plus c. Now, again, if you're not sure, if you're not comfortable, remember you can always take the derivative of this, and it should get you back to your integral. Okay. All right, so there was station 1, a whole lot of integration going on. What about station 2? Well, station 2 looks like this. We've got the integral of x squared minus 5x plus 6 dx. Yes, I do think this is a by-part situation. No, silly. I think it's partial fraction decomposition. Because look, this thing can be broken down into x minus 2, x minus 3. Well, that's perfect for setting up partial fraction decomposition. Here, let me show you. We have 1 over x minus 2, x minus 3. We have a over one of the factors, and b over the other factor. Okay, so I multiply everywhere by the least common denominator, and I end up with 1 equals a times x minus 3 plus b times x minus 2. And if I use some magic numbers, like x equals 3, well, 3 minus 3 is 0, so that goes away. 3 minus 2 is 1, 1 times b is b, and on the other side of the equal sign, I just have this lonely old 1. But wait, there's another magic number. What happens if we choose x equals 2? Well, if I choose x equals 2, 2 minus 2 is 0, this goes away. 2 minus 3 is negative 1a equals 1, and so a equals negative 1. So now this thing that I couldn't integrate, I can actually break that up into 2 integrals now. One is going to be negative 1 over x minus 2, and then I'm going to have this other integral over here with this b value. And even though I'm often want to say, hey, so not everything in the denominator is an ln, actually here I am going to say these denominators do make ln's. And if you're not sure about that, you could always say, hey, what if I made x minus 3 equal to u? And did a u sub? Well, this would be 1 over u, and that's, the derivative of ln of u. So here, negative ln x minus 2 plus ln x minus 3, and don't forget the plus c. I will say that while this is fine in free response, you're not going to see that answer in free response. You're going to see the ln of x minus 3 over x minus 2 plus c. So how'd that happen? Well, remember when we have 2 logs joined with subtraction, that means that goes on the bottom, and the plus sign means that one goes on the top. And there we go. Notice it's not ln on top and bottom. It's just the ln of that fraction. Then sure, I think that's a great idea to put those there. Okay, nice. See, look, we did two problems just then, right? We did the integration problem, and we were able to use partial fraction decomposition in a way that didn't make most of you run screaming from the room. Problem number 2. Okay, so problem number 2 kind of looks like that last problem. But I'm wondering if here I actually have a u sub. Why did I think that? Well, so here's the thing. Do I see a function and either its derivative or part of its derivative present here? Yeah, I see x dx. Yeah. So let's see what happens when I do that. I mean, maybe this is just going to be partial fraction decomposition, but I feel like partial fraction decomposition is not something I want to do right away. So let's see what happens here. If we make this our u, x squared minus 5x plus 6, then my du is 2x minus 5 dx. Well, so here's the thing. You know, I've got an x and a dx. That's good. I definitely don't have that. And I don't really have that. So, you know what? Maybe this is also partial fraction decomposition. So I'm going to have x over x minus 2 and x minus 3. That's going to be a over x minus 2 plus b over x minus 3. And again, I'm going to multiply everywhere by least common denominator to get x equals a x minus 3 plus b x minus 2. All right, so if we plug in x equals 2, that goes away. That becomes negative 1a equals x. So, 2. So we've got a 2 there and negative a. So a is negative 2. Okay. Negative 2 over x minus 2. And then I need another magic number like x equals 3. And that will make this disappear. And I'll have 3 equals b. All right. So this is the thing that I want to integrate. This is the thing that's going to be ever so much easier than this. I tried it with a u sub. It didn't work. I really don't want to go anywhere near it with by parts. So I'm just going to have to take this and find this antiderivative using these pieces. And conveniently, yeah, these are situations where these are going to be ln's. So minus 2 ln x minus 2 plus 3 ln of x minus 3 to the 1 half. To the 1 half? No, let's check. This is going to be 1 over. Good. Derivative of the inside is 1. Nice. And there's a 3 on top. Okay. And so I'm going to stop there, I think. That's as far as I need to go with number 2. But, you know, if this is multiple choice, they're going to condense these logs into one log. And so remember, if there's a minus sign, it goes on the bottom. If there's a plus sign, it goes on the top. So 3 ln x minus 3, and on the bottom, 2 ln x minus 2 plus what? I was condensing this into one log. That's the positive, so it's on top. That's the negative, so it's on the bottom. Oh, right. Gotcha. So here's the problem with that. The problem with that is I have these powers, and they have to be picked up first. So I'm now going to have ln of x minus 2 squared. No, that's on the bottom. There we go, x minus 2 squared. And on top, I've got x minus 3 to the third. Oh, don't forget the plus c. Yeah, so use that power rule in reverse. Then you can combine these into one log, like that. Remember, things in front with a minus go on the bottom, things with plus go on the top. Okay. How exciting. And how about this last one? Oh, it's like they read my mind. Look. So, who remembers from 5 minutes ago what it was that I was saying about this? This is a u sub, where u equals x squared minus 5x plus 6, and therefore du is 2x minus 2x minus 5 dx. Well, that's great, because look, there it is. So I can rewrite this as 1 over u times this is that. So all I need is du here. Well, that's a really easy integral. It's ln of x plus c. And yes, I am going to use absolute value bars. All right. So, we didn't need partial fraction decomposition there, and that saved me a little time. But it also requires me to recognize when I can and cannot use that partial fraction decomposition. Here, because I recognized the derivative of this, I was able to take a shortcut. Station 3. Use a 3×3 slope field centered on the origin to suggest the antiderivative of dy dx negative x over y. Okay, so, well, if I make x equal to 0, so x equals 0, I'm going to have a 0 slope, I think. If x is equal to 0, I've got 0 on top. Well, except when y is 0, because then I have 0 over 0, so I'm going to leave that one. Okay, and what about when x equals 1? Well, if x equals 1, I've got a lot of places to check, don't I? So let's start here. X equals 1, y equals 0. X equals 1, y equals 0, that's undefined. And then over here at x equals 2, okay, I've got a negative 2, and I've got a 0, negative 2 over 0 is definitely undefined. How about negative 2 over 1? Well, negative 2 over 1 is minus 2. And here, now I've got negative. Excuse me a moment. I'll see you in the next